Yeah, the complex medical part machining as an art, or is an art. Complex medical part machining is an art. Oh, look at that chip.
Today we're going to be talking about bone screws. Now I
Oof.
promise we're not going to be machining bone screws. We have plenty of videos on that on our channel. Check them out if you haven't seen them already. But bone screws are an important piece of equipment on the medical field. Just ask anyone who's broken a few bones. They probably have some inside of their body. Thankfully I've never needed them. Hopefully it stays that way. That's fingers crossed. But have you ever wondered what kind of tool is used to put those bone screws into your body? It's obviously not some screwdriver that you can get at the Home Depot, but a much more specialized tool.
I would argue that probably an overpriced DeWalt. Maybe Makita.
Today I'm going to be making a cannulated Torx driver for a bone screw. This particular one is like a bit that would go into a surgical driver in the hospital. What makes it cannulated is the center hole running through it. That allows you to run a guide wire or a K-wire through the bit and through the bone screw. That wire helps guide the bone screw through its intended path into your body so it can be placed accurately and kept in from going in crooked. Like machining, putting in a bone screw into your
Yeah, because sticking in a screw like that crooked, it's not like you can back it out and try again. Ugh.
body is a very precise operation with little room for error. I'm running this part today on the Tornos GT32. We're going to be running it out of 875 7/8
Oh, that is a sexy looking setup.
diameter 304 stainless steel. I'm also going to be running one out of brass like we usually do, so that way I can run the part dry. The 304 needs coolant. There is one exception on running it dry, which I'll explain in a minute, because we're going to have to run coolant on one tool. I'm going to start off by facing the part with a CCGT insert, and then once that face is flush, we're going to run our two drills. We have two Kendrill Micros, 78 thousandths diameter, so they're very small. One's a 2 times D drill, and one is a 20 times D drill. We're gonna start off by running the 2 times D drill first as a pilot hole, and then afterwards, we're gonna run the big 20 times D drill. I need to run cool.
Now you need to do that because if you do it with the long one right away, you could snap it right off, and that gets expensive on tooling. You also might not get a perfectly centered drill hole, which also not good, and especially something like this.
Coolant on the 20 times D Kendrill Micro to make sure that chips don't pack up inside of that hole, since it's a very small hole, and that way I can make sure that the tool isn't going to break. After we have our small hole put into the part, then I'm going to recall the first tool, the CCGT insert, and we're going to rough out the front of the part. I have this roughing pass split into two, so we're going to rough out the first half of the part. Then I'm going to come in with another CCGT insert, and we're going to finish the first half of the part. After that, we can start milling out the Torx feature on the front of the part. I'm using a 94 thousandths ball mill from Kennametal. It's a 2-flute ball mill, and this tool actually has a bigger shank at the bottom where it's being held. So the base of the tool is bigger. That gives us some added stability so that the part doesn't shatter. After we put in the full torque feature, we go around the part 6 times, then we can start on the second half of the part. We recall up our CCGTs, both the rougher and the finisher, to do the second half of the part. After we rough and finished out all the turn surfaces that we can reach on this side of the part, we're going to come in with a dual lock Harvey 1 end mill, and we're going to put the flats on both sides of the part. After we put in those two flats, we can finally do our pick-off operation and part it off. I'm using a 118 wide part off tool, and it's gonna grab the part it off, send it to the second side, and then while op 1's running, op 2 is going on. On the second op, I just have two tools. I have a really small CCGT that is roughing and finishing the second side of the part. And then afterwards, I have a 1/8 end mill, 125 diameter. This is a Harvey 1 TE 4-flute end mill, and this is putting in the pockets on both sides of the part. After it's done with all the milling work, it then goes and ejects the part, and we have a part complete.
And since he's running it on a Swiss machine, a Swiss machine. Yeah, a Swiss machine is made specifically for turning out as many parts as possible in the shortest amount of time. So basically, you load up. I think the Tornos here can take an 8-foot rod of material, and basically, it turns that 8-foot rod of material into finished parts. They're very cool machines. And this is just a little one. They had a bigger one where it had 8 spindles. So it could be running 8 parts at the same time, which is just a wild idea in terms of production.
So let's talk about the drills for a moment. If you remember a while ago, my father put out a video on how to have success when you drill with long drills. I do something very similar on this part. If you haven't seen that video, check it out because it's super informative and it
Oh,
sets you up to have success when you're doing long drills.
long drilling is a pain in the ass. Because it's, you start getting material bound up in the flutes, and it binds up and hardens, and especially materials like aluminum, and I suspect titanium is an absolute nightmare because titanium's weird. It's gummy, and instead of taking heat, it puts the heat into the tool and wears things out faster. Aluminum is gummy by itself, but it's a relatively soft material compared to something like steel.
Drilling. I have 2 drills here. One is a 2 times D drill, one is a 20 times D drill. These are both Kendrill micros. They're exactly the same except for the drill length, so they have the same angle, the same diameter. And we start the hole out with this 2 times D drill using it as a pilot drill. So we start the hole, go as far as this drill can go. I'm running it at 5,000 RPM with a feed rate of 0.8 per revolution. And then after I run this small drill, I come in with the long 20 times D drill. This drill I need to run with coolant through to flush out any chips. We started at a slower feed rate just until I reach where this drill finished off.
So I think that drill, it's got holes in it so that it runs the coolant down the length of the drill, and so it can blast any chips out of the hole, out of the flutes. Which that's where you start. You can run into some problems.
And then we engage it, go full feed, 0.8 per revolution, 5,000 RPM. We go all the way in. I have a slight dwell at the bottom of the hole, and then we pull out the drill, flushing out any chips that are remaining. The hole comes out perfect every time. I know my dad did his video with the 40 times D drill, which was much bigger. It had a bigger diameter. But these 2mm drills, they can be pretty sketchy because of how flimsy they are. So I'm glad it worked, and I didn't have any issues when I did that. All right, so let's run the rest of the part. All right, so we got the part. It looks good. Let's go check it out in inspection. What I'm actually going to do is we're going to zero it out on the face here. That feature looks good. I'm going to run a pin through it now. So let's get this part off of here. Let's check the hole now. So we'll run our go pin through. Seems good. We'll run the no go. Check both sides. It's perfect. Happy with it? Now I just need to find somebody to test it on. So that's our cannulated Torx driver. I'm really happy with how it came out. That GT32, you can make anything on it. Hey, if you haven't already, make sure you check out MFG Connect. We revamped the whole thing. It just got a new update. It's available on all platforms, and it's an easy way to get in touch with me, Barry, and the other guys here at Titans of CNC. And also check out the Titans of CNC website and store. You need machines and tools anyway at your machine shop, so why not get it through us and support a good cause like free education? So check us out, and I'll see you next time.
Definitely cool organization.